So today we'll discuss about practical activity 12, authenticating secure communication using digital signature. Okay. So before we get into the practical, we will just go through some theory things. Just let bit information. Okay. So this one. So this is a diagram which shows how the digital signature is being created, how it is working. So we have a sender and we have a receiver. So the sender want to send a message, see message.txt to receiver. So to make the some communication secure, we'll go for digital signature. Okay, how the digital signature is made? See the process. The sender will send a message. Okay, that message will be sent to hash algorithm. It may be a secure hash algorithm SHA, which will generate a hash or a message digest. Okay, what that message digest means? It is like using some mathematical functions. We generate fixed length string data. Okay, like this, and that particular hash will be encrypted using RSA algorithm, which uses the sender's private key, and the final output will be the digital signature. And this message plus digital signature both are sent to the receiver through network. So at the receiver side, we'll have message plus digital signature. So what we will do is we will apply the same hash algorithm on that message, and they will generate a hash plus the digital signature which we already sent now, that we have to decrypt, and we will get a hash. So if these two hashes are matching, so we'll compare these two hashes. If they are matching, means signature is valid and the receiver will receive the message. This is what the process happening. Okay, digital signature. Now we'll go for the practical part. Go for the practical part. I'll go to the tool. This is a Linux tool. Okay, so in Linux we'll use this terminal to try this command. So actually we use OpenSSL tool or OpenSSL commands to perform this. Okay, what are the steps here? So I'll mention the steps here. Let me check the steps. First thing, generate key pair. So key pair means we have to generate private key and public key. Okay, so here, for encryption, decryption, we need private key and public key, right? So that's what we have to generate the private key and public key. So I'll go for the first command. First command is, sorry, open SSL, then gen p key. What is that? I'll tell you later, okay? Algorithm on SA, then hyphen out, hyphen private underscore key dot PEM. Okay, so open SSL space gen p key hyphen algorithm RSA hyphen out private key underscore PM. What is the use of this command? Okay, we are going to generate first the private key, then we want to display the private key. So first thing, what is open SSL? It is a tool for generating command line tool for generating the private key, public key, digital certificate, hash, everything. For all those purpose, we need to have this tool, OpenSSL, or we have to use this command. Then, what is gen p key? We are going to generate private key. That's why gen p key. Based on which algorithm? RSA algorithm. And we want to display the private key. For that, out the private key dot PEM. PEM means privacy enhanced mail. This is actually encoding technique to make the data secret. Okay, this encoding technique to represent the binary data like certificate in a human readable format. Okay, that one. PM is encoding. So this step is used to generate private key. That's why OpenSSL is the tool or command to generate the key. You can generate private key, public key, hashes, data signature, everything. And then gen p key means generate private key. Which algorithm? RSA. I want to display the private key. That's why out private key.pem. Now, inside this private key, we have public key. Okay, so this private key actually contains public key also. Private and public key both are there. So I want to extract the public key part now. How do we extract the public key and how do we display the public key? Next command, okay. Same open SSL tool. We use RSA algorithm. Then pub out. That means we want to output public key from where? Private key. So hyphen in will go for private, the same private key which we created on the previous step, okay. Dot pem space after generating public key. See, I'm using same tool. I want using the same algorithm. I want to extract the public key, that is pub out, from where? In is private key, and I want to display the public key. So out public key will be public underscore key.pem. Okay, let me check the syntax. Open SSL RSI pub out in private underscore key.pm, same name. Then out, I want to display the public key. So displaying I out. This is extracting, get the public key from the private key. This is display the public key to outside. Now private public key is done. Okay. Now next step. This next step. Sign the message. Now we want to create a simple text message in a file message.txt. Write the content message in that and sign the message with your private key. Okay. So for that, I'm going to first create a text message. Okay. So I'm going to create a text message. You know, in Linux, no, we use a command echo followed by double quotes. Then your message, whatever message you want, just put here. So I'm putting here my secret message. Then double quotes close. Then this redirection operator, then this file name message.txt. Okay, echo is the command to generate a create a new file with content. So double quotes the content, then the redirection operator okay, greater than symbol otherwise. Then we have to mention the file name message.txt. Done. Now produce the digital signature. Okay, so for that, open SSL command again, dgst. What is a DGST? I'll tell you. DGST hyphen SHA256 hyphen sign hyphen private underscore. Say I use tab key, then out signature dot bin message dot txt. Okay. Open SSL. So open SSL, then DGST SHA. See, this is really mistake I have to go for. So that's what I'm checking before entering the command. Okay, SHA256 algorithm, then sign, then private key which we already generated, then digital signature, this one, then message. Okay, now what I need is I want to digitally sign this message. Okay, so for that, what I need is first thing is the tool OpenSSL. Okay, now what is DGST? This message digest. Okay, DGST is the tool for hashing or signing. Whenever you want to generate a signature, or we want to do hashing. Okay, we want to hash the. Remember when I discussed the theory part, I told you about hash. Okay, this is hashing. To perform this hashing, we need the DGST tool. Okay, and we need SHA algorithm. See, SHA 256 bit. This is the algorithm we need. So tool is, and inside OpenSSL we need a DGST tool to generate the digest. Okay, and what is the algorithm we use? SHA. Then we get hash. Then we have to encrypt it using private key. This okay. Now see here the syntax also. OpenSSL, inside that we need DGST tool. Then we use SHA algorithm for generating hashing. Then I want to digitally sign that, okay, by using private key. See the picture. We after that we will encrypt that hash by using private key. Encrypt using private key of the center. That's why we have private key of center. Then we want to display the digital signature. Okay, I'm displaying the digital signature with message. Okay, so message is now digitally signed. How I did that? I use OpenSSL. Inside that I use BGST tool. Then you have to mention which hashing algorithm. After that we want to sign that using private key. Then display the digital signature with the message. Okay, done. Now digitally signed message is there. Now what is the next step? Verify the message using public key to check the signature. Now we are going to verify the authentication. Okay, so we want to verify the message. You see, we encrypted using private key. We are decrypting. Okay, verifying using public key to check the signature. So for that we have the command. Okay, so integrity and all, we are checking the message. Okay, so this one go for open SSL DGST, same SHA 256. Okay, secure hash algorithm. Verify public key. So we decrypt using public key, that verification. Okay, then signature. What is the signature we gave in the previous step? Signature.bin. Okay, signature.bin binary file and message.txt. Okay, so we are going to verify the signature for integrity and non-repudiation. Okay, so mention the OpenSSL tool, DGST tool, the secure hash algorithm. Verify using public key. You are going to verify the signature using public key. The message. Okay, now see the message is verified. Nobody has done any changes in the message because it is verified now. Now what I'm going to do is this is exactly same file which we have signed. Nobody have done any alteration or correction. Okay. Now what I'm going to do is next step, modify the message and verify. Okay, I'm going to modify. I want to modify the content of message. Then I want to verify the content. Okay. So what I'm going to do is echo. See, let me check the file content. Cat message.txt, my secret message. Okay, I want to add some content, edit the content. Echo, then modified message. I'm adding some content, then message.text. After that, now I am going to re-verify that by using the public key. Open SSL DGST, then the algorithm 256 secure hash algorithm. Verify using public key the message with signature, right? Signature. What is the digital signature? Signature dot bin space the same message. Let me check the spelling. I'm cutting out. Okay, open SSL BGST SHA secure hash algorithm. Verify public key, then signature.bin message.text. Okay, now verification failure. Why? Because we have edited the content. We added one message, modified message, So when you are already having the message digital signature, when you are verifying it again, see somebody has changed the content. That's why verification failed is coming. Okay, because hash is now different. When I make some content, the hash generated previously and the hash generated now is different because that content of the that message or text have changed. So OpenSSL will compare the hash and will say it is hash change, so verification failure. Okay, this is how we verify whether the message is being altered or changed by someone during the transit. Okay, now we can do the same thing like when you want, if you want to send a signed message to classmate, what you can do is share this public key with another student, share the message and generate a signature bin with your classmate. Then we'll ask the student, okay, verify the message using provide public and signature. So if there is no change done, means it will be verified successfully. Otherwise, if anyone changed in between, the verification will fail. Okay. Now, if you want to delete that particular data, so okay, the key, that message, everything, no, we can use gen delete, or we can even use that rm command. Okay, so I use rm remove. Okay, or we can use even the gen delete command. Okay, so gen delete, let me try first one. See, gen delete, let me try private key, then public key, then message, then signature.bin, not found. Okay, then I'll try the same with rm. Some versions have gen delete, but I will use rm command. Rm is working. Remove. So see, everything is removed now. When I try ls, it's removed. Okay, this is how we generate the digital signature. This is how we verify the authentication and integrity of messages. Okay, authentication of that sender and receiver, as well as verify the integrity of message by using digital signature. Hope this is clear for you. Okay, I'll upload the activity practical as well as the theory part.